this is a phenomenon that is widespread in nature. There's an underlying symmetry in the basic theory, but which is not realized in practice. For example, I mean, simply if you stand a pencil on end or a pen, that is a perfectly symmetric situation, but if you let it fall, it must choose some direction to fall in. And that is a spontaneous breaking of a sort of rotational symmetry. And spontaneous symmetry breaking seemed to be natural, but it seemed also at the time to be ruled out by a mathematical theorem, the Goldstone theorem, which apparently required unobserved extra particles. And when Jerry Guralnik came to Imperial College, he'd been working on this problem, and with Hagen also, we eventually showed how this could be avoided. And that work led, that work and the work of the other papers, of course, contributed to the development of the electroweak unified theory, the Weinberg-Salam theory, which is now part of the standard model of particle physics. At this point, I guess I'll hand over to you, Jerry.
Give me just a minute here. Okay. Given that Tom has shown a nice picture of himself and Obdus, I should say that Hagen, who has been my friend since we were undergraduates together at MIT, I wrote my first paper with him. We've taught physics ever since. Hagen and I were working hard. Hagen as a graduate student at MIT, I as a graduate student at Harvard. And this is an example of what we're up to. On the left, the person making, I hope, a peace sign is Lord Bob May of Oxford, who has essentially invented the modern field of population biology. There I am sitting at the wheel of that Sunbeam Alpine, 50 or 60 pounds lighter, but you know, it's 50 years ago, and the cool guy with the shades is Hagen. And as you can see, we worked very hard, but what's very interesting about the story, perhaps, is sort of the chains in physics that were involved in this. Hagen was a student, a PhD student at Ken Johnson at MIT, who in turn was a student of Julian Schwinger. And Julian Schwinger was the first person, to my knowledge, to analyze carefully the nature of mass in electromagnetism, and indeed demonstrated that there was no dynamical reason, that is, absolutely firmly built into the theory, for the photon, the thing that makes light, to have zero mass. And if you analyze his arguments, in particular in his two-dimensional model, it turns out they coincide with the arguments that Dick, Tom, and I used later to explain how it would be possible more generally to have a spontaneously broken symmetry, another solution to a theory which looked like it would start out requiring a Goldstone boson, a massless particle, but which in fact did not. And I should mention what's particularly interesting about this. All three groups did their work totally independent. Our work was done without knowledge of the other groups. And in fact, what's very interesting, which shows some of the beauty and the stability of the theory, is that all three groups, by using very, very different methods, essentially came to the same conclusion. And I'll just say a couple other words. I went to, after finishing my thesis with Gilbert, Wally Gilbert, who got a Nobel Prize in chemistry for his work in biology, but was Abdus Salam's student, showing how this all ties together. I went to Imperial College, where I met Abdus for the first time, and Tom. And Imperial College was, I think, looking back on it with my other experiences, Harvard was wonderful. Imperial College was beyond belief. The intellectual excitement going on at the time was just off scale. And we did our work in a wonderful environment. It helps to have such environments. And it resulted in a lifetime physics collaboration, off and on, but certainly a lifetime friendship between the three of us. Now, I should also mention that from our experience, when we did our initial work, I, in particular, was giving talks on it, and it was not believed. It was so different from the context in which most physicists thought in terms of quantum field theory, particle physics, that they really were not particularly prepared to accept this work. Indeed, I was told that the work was essentially wrong by one of the most famous physicists ever, Werner Heisenberg, when Dick and I attended a conference held in Munich in his honor. And we were very young men. It was particularly scary. And so we were very delighted to see that we did something that has survived. We're very honored by getting this prize.